So again, we're going to look at factoring quadratics. Remember, the most important step is to common factor first. This will reduce the difficulty in many of your factoring questions. So starting with example 1a, we notice that there's a common factor of 5. So if we take out the 5, we're left with x squared minus 2x minus 15. Notice now we have smaller numbers to deal with. We need two numbers that add to the b value. Remember, the b value is the middle term, but now we've modified it. So our b value is negative 2. And multiply to a times c, which in this example is going to be 1 and negative 15. And 1 times negative 15 gives us negative 15. So what we need are two factors of negative 15 that add up to negative 2. So take a moment, think of factors of negative 15, and find a set of factors that add up to negative 2. You should end up with negative 5 and positive 3. So we take our expression. Remember, the 5 is the spectator right now. We have x squared minus 5x plus 3x minus 15. We took that 2x and split it into minus 5x and positive 3x. Next, we're going to factor by grouping. So we have 5. Common factor for x squared minus 5x is x, and that leaves us with x minus 5. Common factor for 3x minus 15 is 3, and that leaves us with x minus 5. Which is great because now we see that both terms have the common factor of x minus 5. Taking out the x minus 5 leaves us with x plus 3. So here is our factored form for 5x squared minus 10x minus 75. Alright, let's try this one more time. So again, start by common factoring. So we notice in this next example, b, that we have a leading coefficient that's negative. And we're reminded that when we see a negative leading coefficient, we should take that negative out. So if we take out the negative 1, we're left with 4x squared minus 12x plus 9. Next, we need two numbers that add up to negative 12. That's the b value of this expression. That multiply to a times c, which in this case equals 36. Because there's our a is 4 and our c is 9. So think of two numbers that multiply to 36 and add to negative 12. So hopefully you found that they are negative 6 and negative 6. So our next line will be negative. We have 4x squared minus 6x minus 6x plus 9. And there's our negative 12 split up into 2 minus 6's. Again, we're going to factor by grouping. So in the first group, we're going to take out a 2x, and that leaves me with 2x minus 3. And again, we have a negative leading coefficient, so I'm going to take out a negative 3 in the next pair, and that leaves me with 2x minus 3. Which is great because now we have the common factor, 2x minus 3. So for our final line, we have our negative 1. We take out the common factor of 2x minus 3, and we're left with 2x minus 3. So there's the factored form of negative 4x squared plus 12x minus 9. In our next example, we're going to sketch each quadratic using the x-intercepts and the vertex. In our last unit, we would have used a table of values, and you would have had to been given the x values to graph your parabola. Now that we know how to factor, we can determine the zeros, the axis of symmetry, optimal value, and vertex for any quadratic that we can factor. So let's start with this first example. The first step we want to do is factor this expression. So again, our first rule is common factor first. So if we take out a negative 2, we're left with 4x squared minus 49. Recall that we are missing the x term, so one way to rewrite this is to add a 0x into our expression. So for this quadratic, we need two numbers that add up to 0 and multiply to 4 times negative 49, which equals negative 196. So since they have to add up to 0, we need a positive and negative number that are of equal magnitude. So a quick way to figure this out is to take the square root of 196, which gives us 14. So the two numbers that will work are positive 14 and negative 14. They add up to 0 and multiply to negative 196. So let's continue. So we have negative 2, 4x squared, plus 14x, minus 14x, minus 49. We split up the 0x into positive and negative 14x. Next, we're going to factor by grouping. The negative 2 stays out front. The first pair of terms has 2x as a common factor and leaves us with 2x plus 7. And the second set of term, again, has a negative leading coefficient. So I'm going to factor out a negative 7, and that leaves me with 2x plus 7. We now have 2x times 2x plus 7 and negative 7 times 2x plus 7. So we have our negative 2. We remove our common factor of 2x plus 7, and we're left with 2x minus 7. We now have our quadratic in factored form. But remember, we want the x-intercepts and the vertex. So to find the x-intercepts, or the zeros, we're going to let y equals 0. And if we do that, we get 0 equals negative 2, 2x plus 7, and 2x minus 7. Next, we're going to solve for all the factors that contain an x. So we have 2x plus 7. I want to know when that equals 0. And 2x minus 7. When does that equal 0? If we solve these equations, we get 2x equals negative 7. If we minus 7 from both sides, dividing both sides by 2, we get x equals negative 7 over 2. That is our first 0. Similarly, adding 7 to both sides for the second one gives us 2x equals 7. Dividing both sides by 2 gives us that our second 0 is 7 over 2. So we can leave them as zeros, or if we want to write them as x-intercepts, that would be negative 7 over 2, comma 0, and 7 over 2, comma 0. Once we have the zeros, or the x-intercepts, we can now find the axis of symmetry, which remember is the average of the two zeros, which in this case is negative 7 over 2 plus 7 over 2 divided by 2. And that'll give us 0 over 2, which means our axis of symmetry is at x equals 0, or the y-intercept. We can find our optimal value by subbing x equals 0 into our original equation. So we get y equals, and going back up, we have negative 8x squared plus 98. So negative 8, 0 squared plus 98. Negative 8 times 0 squared is 0, so we end up with a y value of 98. And therefore, we have a vertex at 0 and 98. So we have three important points, our two x-intercepts and our vertex, which is also a y-intercept in this example. So if we go back to our graph, we can plot those points. We can say that's negative 7 over 2 and 0. Here is 7 over 2 and 0. And then we have 0 and 98. And notice we have a parabola that opens downwards, which matches the negative a value we have in our equation. So notice the negative a value, which gives us this parabola that opens downwards. Let's try a couple more. B, 5x squared plus 15x. Remember, common factor first. If I take out a 5x, notice I'm left with x plus 3. And I don't need to even go any further with the factoring because I now have all my x's with an exponent or a degree of 1. So I can go right to finding the zeros. So I'm going to let y equal 0. So we get 0 equals 5x, bracket x plus 3. I can solve for each of the zeros. So when does 5x equal 0? And when does x plus 3 equal 0? So if we divide both sides by 5 for the first 0, I get x1 equals 0. If we minus 3 from x plus 3, we get x equals minus 3. That's our second 0. We can now get our axis of symmetry, which again is the average of the two zeros. So 0 plus negative 3 over 2, which tells us we have an axis symmetry of negative 3 over 2. And finally, we can get our optimal value, which we can determine by subbing in the axis symmetry into our equation. So we have 5 times negative 3 over 2 squared plus 15 times negative 3 over 2. Order of operations, we get 5 times 9 over 4 minus 45 over 2. Recall that is 15 over 1, so 15 times negative 3 is negative 45. 1 times 2 is 2. This is 5 over 1. So we end up with 45 over 4 minus, making this an equivalent fraction with a denominator of 4. This would be 90 over 4. And we end up with negative 45 over 4 as our optimal value. So this tells us our vertex for this expression is negative 3 over 2 and negative 45 over 4. So now we can plot our points. We have our two zeros, 0 and negative 3, and we have our vertex, negative 3 over 2 and negative 45 over 4. So let's plot these. So we have negative 3, or if you like, negative 3 and 0. We have 0 and 0 as our second 0, or x-intercept. And we have negative 3 over 2 and negative 45 over 4. So again, this is just a sketch. So we get negative 3 over 2 and negative 45 over 4. Notice this time the parabola opens up. And that's great because our a value is positive and this parabola should open up. If we go back to the top, we saw our a value is positive 5, which means we have a parabola that opens upwards. All right, last one. So recall that if we want to factor an expression that has a negative leading coefficient, we should common factor out the negative number. So we're going to take out the negative 1, and we're left with 4x squared minus 13x plus 3. So in this example, we need two numbers that add up to negative 13, the b value, and multiply to 4 times 3, which is 12. So factors of 12 that can give us negative 13. Well, here are the two magic numbers, negative 1 and negative 12. Multiply them together and we get positive 12. Add them together and we get negative 13. So for the next line, we get negative 4x squared minus x minus 12x plus 3. So we split up that negative 13 into negative 1x and negative 12x. Again, we're going to factor by grouping. So we get negative, take out the common factor of x, 4x minus 1, take out the common factor of negative 3, and we get 4x minus 1. Remember, when we see that leading coefficient that we're factoring as negative, we want to factor out the negative. Finally, we have negative. We take out the 4x minus 1 from both terms, and we're left with x minus 3. So there's the factored form for this quadratic. Next step, let y equal 0, since we want to find the x-intercepts. So we get 0 equals negative 4x minus 1, x minus 3. Setting each factor equal to 0, we get 4x minus 1 equals 0, and we get x minus 3 equals 0. Solving for x, we get 4x equals positive 1, and therefore x1 equals 1/4. And then for the second 0, we get x2 is equal to 3. So there are our two zeros. Next, we need the axis of symmetry. And remember, the axis of symmetry is just the average of the two zeros. And we get 1/4 plus 3 over 2. So now we got to work with our fraction skills. That's 1/4 plus 12 over 4 divided by 2. So that's equal to 13 over 4. And if we divide by 2, that means we multiply by a half, which gives us an axis of symmetry of 13 over 8. Finally, we need to get that optimal value. And we know we have negative 4x squared plus 13x minus 3. So we have y equals negative 4 times 13 over 8 squared plus 13 times 13 over 8 minus 3. The next step is to evaluate this y value. So we get negative 4, so that's 169 over 64. We square that, plus 169 over 8 minus 3. But remember, this is 4 over 1, this is 3 over 1. If you keep working with your fractions, you'll end up getting 121 over 16. So our vertex is 13 over 8 and 121 over 16, which you could approximate or evaluate using a calculator. That would give us 1.625 and 7.5625. So now we can plot our points. So there's our vertex, approximately 1.6 and 7.6. Here are our two zeros. So if we graph that, we'll say that maybe this is a quarter here. So 1/4 and 0, or 0.25 and 0. Let's say that's 3 and 0. And then again, our vertex was 13 over 8 and 121 over 16. So 13 over 8 and 121 over 16. This time we have a parabola that opens down, which again matches our a value from our equation above, which we see is negative 4.